Alright, this is lesson 9.5, Intermediate Algebra, and I'm going to do a couple problems from the problem set. So let's go ahead and look at some of those. I'm going to jump clear down to one like, well, let's look at number 43. We've got the square root of 3 plus 1, and we're cubing it. So that means it's going to be this times this times this. Okay, so what we're going to do is we're going to do the FOIL method 3 times. So we're going to do it, or twice. We're going to do it right here. So the first term, the first one, square root of 9. The outside ones, 1 square root of 3. The inside ones, and the last ones. We're going to combine. Whoops, let's just do square root of 9 is 3. These two added together, and we get that when we FOILed these first two right here. Now we're going to take that one and put it down here. Alright, so then we're going to take this times this, and then times that. So 3 square root of 3 plus 3 times 1 is 3. Then we're going to take this one and do it times that and that. So 2 square root of 3 times the square root of 3 is 2 square root of 9. We'll just leave that. And then this times this. Oops, 1 times 2 square root of 3 is 2 square root of 3. Now we're going to do the 1 here times this and times this. So that's going to be 1 times the square root of 3, and 1 times 1 is 1. Alright, we're going to combine what we have. We can combine that with that and with this, since they all have square root of 3. So 3 plus 2 is 5, 6. Okay. We have this 3, and this square root of 9 is 3. And if I take it times this 2, I get 6. So 3 plus 6 is 9, plus 1 is 10. And that is the answer to that, which I would really switch this around. Usually you put your radical last. So we get that for an answer. Now when we have one like 46, where we have the cubed root of 5 plus the cubed root of 3, and we're multiplying that times the cubed root of 9 plus the cubed root of 25. The hardest thing you have to do here is put the cubed root in there, and don't forget, and make it a square root. So again, FOIL method. This times this. First one's cubed root of 45. Again, it doesn't matter if it's cubed root or square root right here. Just multiply. Outside, cubed root of 5 times the cubed root of 25 would be the cubed root of 125, 5 times 25. Inside, these right here. And then last, plus cubed root of 75. Now we're just going to see if we can reduce these at all. And again, I'm looking for things that I can reduce, that I could possibly take the cubed root of. Can't really do anything with that, because we can reduce that to 9 times 5, but I can't take the cubed root of either one of those, so I'll ignore that. Cubed root of 125 is 5. 5 times 5 is 25, times 5 is 125. Cubed root of 27 is 3. 3 times 3 is 9, times 3 is 27. And I can't do anything with the cubed root of 75. So I end up with 8, because I'm going to add those together, plus the cubed root of 45 plus the cubed root of 75. Probably the hardest thing about these is just remembering that you're looking for the cubed root, not the square root. And that you're looking for the cubed root, not the square root. So what number times itself 3 times would give you 75? Well, there isn't one. In fact, you can't even break it down and say, well, do I know the cubed root of 25 and the cubed root of 3? Because 25 times 3 is 75. You can't take the cubed root of either one of those. You can do the square root, but that's not what we're looking for. So that's the hardest thing, is just to remind yourself that you're dealing with cubed roots instead of square roots here. So this is number 61. So let's go ahead and simplify that first. So that's going to be that on top, and then we'll square root the bottom. So we just split those up a little bit. Okay, now we're going to simplify the top. So 32, if we use our factor tree, two, 3, 4, 5. So 32 is 2 to the 5th over 2 squared. Okay, so this is simplified now. Now we can actually do some work here. Get this out of my way. So again, there's a 2 here and a 2 here. So how many times does 2 go into 5? 2 goes into 5 twice with 1 left over. Okay, so 1, 2 left over. 2 goes into 3 once with 1 left over. And there isn't an exponent on the y, so we don't do anything to it. On the bottom, 2 goes into 2 once with none left over. And our x has nothing, so it stays in there. 2 goes into this 2 once with none left over. So that ends up being our simplified version. Now we can start looking at ways to cancel. Okay, so we're going to move this up a little bit, and we're going to make this a 4. Alright, so if we can cancel that with that and get a 2. So we have 2x square root of 2xy over y square root of x. Alright, and this is one thing a lot of people forget. This here can be split into square root of 2 square root of x square root of y over y square root of x. Now we did that. I mean, it's just really easy to do, because like if you say square root of 2 times the square root of x is the square root of 2x. So all I did is took this and went backwards and split them up. That gives us a chance to cancel. We can cancel that with that, and we end up getting 2x square root of 2y over y. And at that point, we are simplified as far as we can go. Okay, this is number 64 in problem set 9.5. So again, I'm not going to rewrite it, but you remember you can split these up into 2 radicals, and then we simplify. So we're going to take, instead of the square root of 18, we're going to write it as 3 squared times 2, 9 times 2, x cubed y squared z to the 4th. Notice the only ones you really simplify are the numbers. Everything else stays the same. 2 to the 4th power x y cubed z squared. Okay, so remember this is a 2 here and a 2 here. So how many times does 2 go into the 3 squared? It goes into it once with none left over, so nothing goes in the radical, no number. I have a 2 without an exponent, so you never do anything with that. 2 goes into this 3 one time with 1 left over. 2 goes into this 2 one time with none left over, so nothing goes in there. And it goes into this twice with none left over. So that's the simplification. Whoops, I tried to erase that extra long line, but it's not working. That's the simplification of the top. Now let's look at the bottom. 2 goes into 4 twice with none left over, so no number is under there. X, there's no exponent. 2 goes into 3 once with 1 left over, and 2 goes into 2 once with none left over. So there's what I've got. Alright, so let's see what I can do here. This 3, nothing happens to it, because I'm looking at going across the line here and reducing. And this here is a 4. 3/4 can't be reduced. I do have a y here and a y here that can be canceled, so I've got an x, z, oops, I'm sorry, I've got a z there that can be, one of those can be canceled with that, so I've got 3x z square root, I'm going to split these up, over 4 square root of x square root of y, and then I can cancel this x with this x. Okay, so that gives me 3xz square root of 2 over 4 square root of y. Okay, and finally let's do number 78. And then we'll call that good. Square root of 5 minus square root of 3, square root of 5 plus square root of 3. Alright, so remember we multiply by the conjugate. I'm going to go a little bit fast because I'm running out of time here on my recorder. Okay, so these two, what you do is you square the bottom, or each part. So the square root of 5 squared is 5. Square root of 3 squared is 3, and you put a minus sign. Okay, so that's the big thing, is for the most part you just take the radical sign off there, and put a minus sign. Here we're going to have to do the FOIL method. So my f is going to be first, outside, 5 times 3, inside, 5 times 3, and last, square root of 9. So that gives me on top, square root of 25 is 5, minus 2 square root of 15 is right here, plus square root of 9 is 3, over 2, equals 8 minus 2 square root of 15 over 2. Okay, I'm going to split those up. 8 over 2 minus 2 square root of 15 over 2. And that allows me to get that to be a 4, and these two to cancel. And that simplified it to 4 minus the square root of 15, and that's number 78. So that's it for the problem set of 9.5. So follow those, and you shouldn't have any problem with the homework.